Good afternoon, everybody, and welcome to the Fishbowl. My name is Addison Snell. I'm with Intersect 360 Research, and this has very quickly become an absolute highlight of my ISC week. We introduced this panel format 2 years ago at ISC 23, and I have to tell you, I was as nervous as I've ever been before any talk or panel in my life, and I'm a pretty accomplished speaker, but we had no idea how this was going to go. John Schauf and I had kind of worked out this format where I'll be moderating a panel of experts on the future topics that we see in HPC and AI. And so what's special about that? Well, what makes this fun is for every panel that you've ever been at where someone in the audience wants to ask a question where their question is really a different answer to all of the different topics that they've already heard so far, well, now we've got a chair for you. Every 7 minutes, we're going to very politely dismiss one of our panelists and replace them with a volunteer from the audience. So if you have something that you would like to say and contribute to the panel, please check in with Eric Schneff, who's now waving his hand in the aisle. He's going to help be my accomplice in queuing up who will be taking the next volunteer role coming in. It can be absolutely anybody. There's no pre-qualification for that. I really do, I see a few likely candidates in the audience, but really I hit this podium not knowing who all the panelists are going to be. I have a list of possible topics in front of me, but I'm going to be guided by the conversation that we're having and who's in front of me, and we'll see where we go today. We might use all or none of these topics. We'll see how it turns out. The rule when you come up on stage, especially because I might not know who it is coming up, everybody joining me on the stage is asked to please just introduce yourself, who you are, what organization you're with, and please keep the conversation going by politely disagreeing with something that you've already heard and give us your take on that, and then we'll just continue the conversation from there. With that, I do have a starting panel to kick us off representing our various keynote topics from ISC this year. We'll start up on stage with Yutong Liu from Sun Yat-sen University, who's giving a closing keynote, Bjorn Stevens, Max Planck Meteorology, who's got a midweek keynote, and Scott Ashley, who was part of our opening keynote from Oak Ridge National Laboratories. Please, the three of you join me on stage now, and let's kick off the Fishbowl. I love this. The panelists are all meeting each other. This is terrific. All right, let's get the clocks running. So we got to dive into it. I'm going to start with Yutong on this first question because I'm really intrigued by some of the topics you're going to bring up in the closing keynote. We're not going to have time to hit the whole keynote today, but one of the main questions that's been raised by our HPC-AI Leadership Organization Advisory Committee worldwide is looking at the challenges of building out heterogeneous systems that are able to address a widening range of workloads. As we were talking about a lot of modeling and simulation, of course. 10 years ago, they started telling us we had to do big data and analytics. Now there's all this machine learning, and I'm trying to put a supercomputing in to meet these expanding workloads. Presumably, you didn't get triple the budget. What do you think are some of the challenges in architecting systems that you're going to install now and hopefully get some kind of lifespan out of over the course of their use?
Okay. Actually, I think for many years, we always discussed about what kind of the system, especially the supercomputing system, we should build. The two aspect debate is in focus on the general purpose supercomputer or the specific purpose. For us, because I also in charge in the supercomputer center, we have a need to face a lot of users come from different domain. So for me, I prefer the general purpose HPC system. But we need the system could meet the requirements from the customer writable rapidly and to fit the different domain requirements. So for the general purpose supercomputer, we need the system. I think the ultimate goal never change for the past 40 decades. We need the high performance, the large capacity, the high bandwidth, and also the high reliability, and also we need the low power consumption. But the demand broad for the past few decades. No matter in the simulation for the different demand, those years the large capacity of AI application, and also the phenomenal large language model. So there are quite different requirements for the system.
Well, what I like about this answer in particular is you dove immediately into special purpose versus general purpose, which implies that if you have an application in mind, you'll build something different that's specific to that application. I want to go to Scott next on this, because at a national lab, you must deal with the same push-pull.
Yeah, so different labs have different missions. So some of the labs in the U.S., stockpile stewardship, have a very defined set of applications, so could be a little more specific. But as an open science lab, we have hundreds of applications, and they change every year. So about a third of our user base turns over. So even if you fine-tune something for your largest application this year, they might not be your largest application next year. So we've got to stay general. We view for our workload, which is hopefully full machine workload, that the design is going to be very similar for both AI and for traditional modeling and simulation. The difference is precision. Do you need a precise answer, or do you need an approximate answer? So we need to be able to do both, but as far as bandwidth in the node, bandwidth between the nodes, it's very much the same. For us, really, the only big difference is going to be the file system that serves those two use cases, because one is very write-intensive, the other is read-intensive.
Well, now, Bjorn, you're at an agency that does have a specific domain, at least, around meteorology. Does that give you a different perspective on this? Hey, I know what my top applications are. I can really dial it in for something.
Yeah, I wonder, when I was thinking about the general purpose computing, my sense of the profile is that there's fewer and fewer applications which will scale across the whole machine. Maybe it's still true, but if you look at Frontier, what fraction of its cycles are actually used by a single application? And if that's high, then it makes sense. But as that goes down, then it changes the profile of use. And once in a while, I wonder if we aren't thinking enough about the ecosystem of computing. So we'll have these sort of frontier machines, which are really pushing the edges of technology and are sort of experimental. But if we step back from that, so right now our biggest applications we can run across Jupyter, but really the efficient use of Jupyter would be sort of running on 2,000 GH200 nodes, not on 6,000 or 7,000.
This is a perfect note to come back to you, Tong, on, though, because it implies that maybe this idea of general purpose computing, is that endure, or should we break this up into multiple special purpose clusters? What do you think?
Yeah, in China, the supercomputer center not only service for the scientists, they also need to serve it to fulfill the industry and the other social users' requirements. So for us, we with the quite kind of the architecture we have delivered by our vendor. So we need to establish some, the modulable and adaptable software environment to make the rapid integration for the domain requirements. So we put many efforts in the software to build the hybrid software stack to scheduling and running the HPC and AI converge workload to running efficiency, and also the scheduling for the heterogeneous resources, and also to tackle with the mixed precision computation for the the different application, and in the we call it a proper power consumption, and also we need to do the harmony environment for the different domain. It reminds me that for the era in the software engineering, the talk about the software-defined system. For our supercomputing center, we'll try to do its domain application-defined HPC environment.
There's a lot of fantastic content, and then I look forward to learning more about it in your closing keynote. Please thank Yutong Liu for me.
Thank you.
That 7 minutes goes by very quickly. Eric, do you have another panelist for me? Andrew, come on up. Please say who you are, what organization you're with, and kindly disagree with something you've already heard.
Me disagree with something? So I'm Andrew Jones. I'm from the supercomputing team in Microsoft Engineering. So we're building all the supercomputing infrastructure behind Microsoft's AI mission and our HPC services. Disagree with something. Lots of answers around infrastructure and around what we're doing with the software. What about the people? How are the people going to be the ones that change? How do we have to change the people we have working in HPC? How do we have to change the people working in AI so that they come together, learn skills from each other, and then also learn how to actually apply these AI techniques into machine learning, how to apply them into business, how to answer the questions of which is the right technique used at the right time. So at an application level, at an infrastructure layer, that's for me the interesting question. Is that changing now to what we've been used to over the last however many years? Do we need different types?
You're doing my job for me by introducing new topics. I think there were actually two things in what you just said. I'm going to split them apart, and I want to do both, including the people aspect. But I think implicit in what you said was the notion of how we're balancing HPC and AI, which goes directly to the special purpose, general purpose. And before I lose Bjorn, I want to zero in on that because weather simulation is an area where we've heard a lot about the advancements of AI, and yet I don't think we're entirely ready to drop simulation yet either. How are you viewing this balance of where do we continue with simulation and where do we explore where predictive AI might start taking that role?
Well, I'm not so clear on predictive AI being as great as people think it is. What AI is really good at is telling you the information content of the data. So where you have data, you can use AI. Where you don't have data, I see very, very, very few examples of where AI has done, I can't hardly think of any examples where AI has done something surprisingly good. And so when you look at predictive, all it's telling you is that in the accumulation of data that we have for weather over 40 years, is that the information of how to go from one state to another state is roughly there. We have the data. When it goes to climate, of course, we don't have the data. And so we need to make the data. And so the only way to make the data is from the laws, from the physical laws that we have. And then when we have the data, we can use AI as a coarse-grained or a mega compression of that data. But this idea that somehow AI is going to understand things on its own is pretty fanciful, and I just don't see a lot of evidence.
Terrific. So, Andrew, you never disagree with anything, but Bjorn has never seen AI do anything remarkably good. Agree or disagree?
That's not quite what he said. He said he's never seen it come up with anything new and remarkably good in a scientific context.
I see.
In a broader context, AI has done all sorts of remarkable things, generating and everything from generating movies from a small script yourself to generating the script in the first place. So generative AI can do some amazing things. In a scientific context, I would agree that they're expecting a model that has been trained on a previous context to then infer what might happen outside the context from which that model has been trained is probably a pretty ambitious ask at the current state of affairs.
All right, Scott, you had a terrific AI supercomputer, not just Frontier, but going back to the Summit, Sierra Summit going in. That was heralded as a great AI supercomputer in 2018. So, what's been your view of this intersection between HPC and AI and the workloads at Oak Ridge?
So it's interesting, when we picked that solution, they didn't tell us about the tensor cores. In fact, they didn't tell us until they publicly announced at GTC that the Volta would have tensor cores. And we're like, what's a tensor core? And then it's like, oh, we got a whole bunch of those. How can we use those? So there was a big push to try to take advantage of these throughout the computing directorate, both on the facility side and the research side. There's been a lot of interest in just exploring what the hardware can do and trying to find applications where we can integrate it to help improve the speed to solution. The goal is insight. It's not to, the goal is not to do math. The goal is to get insight. And if we can use, the low precision AI techniques to get us that insight, that's great. If we can use that hardware in a new way that's not quite AI, we've done that as well. So, it's taking advantage of what you have and getting as much insight as you can.
All right, back to Bjorn. I apologize for having put in your words in your mouth a little bit. It's my job to shake up the panel. But going back to what you were saying, it sounds like that you're thinking it's really a simulation world for the foreseeable future for your institute. You're not really anticipating that AI is taking over those workloads in the short term.
No, I think AI is great for doing stupid things faster, kind of like coffee. And most of what we use it for are the things that we know how to do, and it just helps us do them better and quicker and easier, and that's super. I mean, it's not diminishing it just because, that's how most of us use it. It's really great. We know how to draw an elephant. It does it quicker and faster. When it comes to climate, I'll just pose that to the audience. If I had an AI model and it simulated today's climate, and it made just a perfect simulation of the climate system as we knew it, and then I simulated it forward in 100 years, and it told us that the climate wasn't going to warm, would then we just say, oh, hell with all of this stuff about global warming and give it in, throw in the towel? Or if it said it was going to warm twice as much as we think, would we say, oh my goodness, let's stop the world economy now? Because we, of course we wouldn't. And so I really don't see what it has to add in that way. But it will allow us to do all those other stupid things faster that we need to do.
I beg your pardon, but before I throw you off the stage, I will partially disagree with you. I think if there were an AI model of any quality that ran it 100 years forward and said there's not going to be global warming, a number of people would pick up on that and say we don't need to do any of this research. It might not be people in this room, but there would be a lot of them, and some of them would be powerful.
But they don't need the AI model for that thought.
No. They don't need an AI model for the thought, but the AI model validates the thought that they already had. That's my point. And Scott, I will let you talk, but thank Bjorn Stevens for me for coming up. And who's our next panelist coming up? Horst Simon, I've heard of him. Horst, I just said your name, but for the record, please state your name and your organization and kindly disagree with something you've already heard.
Good morning, my name is Horst Simon. I'm the director of Adia Lab in Abu Dhabi, United Arab Emirates. And I gotta make this one statement. A lot of people here ask me, so how are things in Saudi Arabia? So I tell my German colleagues, this is just, if you ask somebody who says, I'm from Vienna, how are things in Germany? Just to give you that as a reminder. So now in terms of disagreement, so I would say I'm a little bit disappointed with the discussion because it's the future of AI and HPC. And I haven't heard much about the future of AI. And I have, in my mind, constructed 4 scenarios, and this is like you usually do scenario planning. And so think about a usual quadrangle, where future of AI is good, future of AI is bad, and AI will develop rapidly or AI will not develop rapidly. So let's explain those 4 scenarios. For good.
I'm not sure I've got time for 4 scenarios as part of an intro right now. Is it quick?
I'll be quick. The good AI and positive is AI will solve everything, will solve climate change and cure cancer, and we'll live in a happy golden age. We hear a lot of people talking about this. AI is developing rapidly and it's bad. It will control the society, will take away your jobs. Everything will be miserable and there will be social control and fake media. Then AI will not develop, then there is a good outcome, and this I would call is the .com bust model, is that all the nonsense will just fade away, but the infrastructure that will be built, just like the internet infrastructure that was built during the dot-com boom, will remain, and we can use it for the next 15 years for happy computing. And the eye is, things are going bad, is there will be a complete bust, and it will be an economic collapse, and it doesn't really matter. And so AI will just be a contributor to the economic collapse.
Okay, so my
So
panelists
in all-
keep doing the job for me of introducing topics. It's a good fishbowl when I'm not really needed up here. Scott, you've been waiting to get in on some of this.
Just on the on Bjorn's last topic, validating scientific AI is still an open question, and that is something that we need to do. And I agree with him completely that interpolation is its strength and extrapolation is the challenge, but I don't believe it's impossible.
Yeah, can we do peer-reviewed AI papers? Can AI peer review AI? Go back to Andrew. What do you think?
I mean, I think we were just briefly mentioning this. There's a next stage beyond that, which is explainable AI, which is trying to understand why the AI is doing what it's doing, why it's presenting a particular conclusion. So if we can start to crack that problem in the context of scientific use of AI, then we may have some advances that are really quite powerful. But it goes beyond just putting it in. It goes beyond having a result you trust. It's understanding why it came to that result. And has it come to that result in a way that demonstrates a new understanding of physics that a physicist or a scientist can go and understand and then build another numerical model of? And I think that is a hope. There's research areas on it at the moment. That will be a significant event.
All right, so we have the opportunity to really look into the future, which Horst was asking us to do, particularly with respect to AI. And I just published an article in HPC Wire a couple days ago, the title of which was HPC Finally Found Its Killer App, Can It Survive? Talking about the AI market now being so much larger than the HPC market. HPC is a segment of it. We've been talking about the need for ongoing science and simulation, but right now, all the money is going in AI, and a lot of the upcoming skills that you were talking about are AI-driven skills. So let's talk about the future then of the talent base in HPC if everyone's coming into the industry thinking AI. Andrew, you kicked off this topic, so start.
So it's not necessarily people coming in with an AI set of skills that we're trying to bring into HPC. Quite often it's actually the reverse. We're trying to pull people from the HPC background into the AI infrastructure and into the AI applications and so on. And the question then is, we can do that because we're making use of that historical knowledge that we've built up in terms of running large-scale applications and running resilient infrastructures at scale and so on. The question is, what are we going to see from the skills that are coming up in the future? And how do we, in the same way we have to work with the infrastructure we have, the ability of the HPC industry to seriously influence the skills that that our employees are going to have in 10 years' time is relatively low. We've tried it for decades in this industry, never really significantly swerved the future talent that comes into us. And so the question is, how do we work with what we're going to be given as a HPC industry in the future?
So we have a big challenge. I will posit this right now. We've got probably 500 interns, maybe 600 interns on the campus right now for the summer at Oak Ridge. And I will posit right now, every single one of those is a supercomputer user, but they don't know it. They're using ChatGPT to do their homework. They are using supercomputing resources on a daily basis. And so when they come to us, they might expect to use a Jupyter notebook and never do an SSH session into the computer, right? So us old farts, we just, VI and Emacs and SSH, and we're perfectly happy. They may never ever see that and be able to use the full system. And so we've got to be able to provide them the tools that they're comfortable and familiar with to let them do so.
Have you lost any HPC people into this world of AI that Andrew's talking about?
Oh, they may have hired a few.
Yeah, I thought so, and I think that affects things. Scott, thank you very much for joining us up here.
I propose Evangelos.
Come on up. Am I twisting your words too much, Andrew? No, you're fine. You're okay. We're good.
Totally unprepared, completely off guard.
That's okay. So am I. Totally unprepared and completely off guard. Please introduce yourself and what organization you're with, and kindly disagree with something.
Okay, so Evangelos Floros, I work for HPC. I'm the head of infrastructure. And through my role, I've been overviewing the supercomputing acquisition program, Lisa, Leonardo, all this, the exascale program for EuroHPC, and now recently the AI factories that we are selecting and deploying in Europe.
Okay, and what do you think of the panel so far? Anything you'd like to contribute?
I think it's hot topic. That's why I joined the room. I came. I think it's something personally I wanted to follow. Look, in terms of AI HPC, we are EuroHPC, so we are not Euro AI. So this is how we started. But as everyone understood, we kind of refocused our purpose towards AI. Essentially, recognizing that it's disruptive and it's close to HPC in terms of requirements for supercomputing power. And that's why when Europe decided that we need to invest on this technology, it's important, it's critical for the industry, it's critical for the industry and the society. EuroHPC was the perfect candidate to take over the program.
Horst, you've been holding your mic up. You're ready to get back in there.
Yes, I wanted to comment back on the statement you made on AI is the killer app for HPC, and I just want to strongly agree with this and take it one step further and just want to make the point that AI and HPC, as we move in the future, are sort of linked together for better or worse. AI is the killer app for HPC, but AI cannot be thriving without the HPC knowledge that has to go into building the infrastructure to support AI. So these are almost the same thing. And so talking about two different things is beside the point.
I agree with that, and certainly AI was built on HPC technologies, but now AI is steering HPC technologies. And we've talked a lot about this in terms of compute. Scott brought up reduced precision. I think we're going to talk a lot about precision in this conference. I'm interested this week in a lot of the other areas outside of compute. What influence do you see in like networking or storage architecture, system software, and is AI having an influence on HPC's evolution there? Anybody?
Well, when we first started with the AI program, and my thoughts were, okay, we have the perfect machines. The architecture that we're deploying are perfect for AI workloads. They were not. I mean, they were very good. That's why we're already offering resources.
They were better than anything else was.
Exactly. However, looking into more detail and learning more, we understand there are specificities there that we need to take into account, and we need to rethink how we design the system. So it is HPC systems, but done a bit differently. In terms of networking, definitely in terms of processing. GPUs, we see how the industry is deploying now AI-specific GPUs, inference-focused CPUs. We need to take these things into account now when we're deciding AI systems. And what we're hoping, of course, is through this infrastructure we're deploying, we're not going also only to satisfy AI workloads, but traditional HPC will also benefit.
Andrew, same topic.
Yeah, I think it's... So what do I want to say here? I think there's a whole list of topics here. So I mean, I think the idea that the AI industry is steering the HPC is partially true. It's certainly steering some parts of the space, particularly on things like GPU futures and so on. I would not say it is steering all of the space, particularly when we talk about user software infrastructure and even maybe some of the storage capabilities, although storage is being stored by AI as well. And the question then is how much, not so much how much is it steering it, but how much is it steering it in a way that is mutually beneficial to both communities versus potentially causing a divergence. And I think then related to that is going back to to the point that was earlier. So AI absolutely wouldn't exist without the supercomputing background, even more so than the breadth of HPC, that really peak supercomputing capability was required to create the AI revolution, if we want to use that word. The question in reverse might be worth asking, do we foresee ourselves ever talking about HPC without mentioning AI for the foreseeable future. So do you ever see a HPC conference in the next 5 years that does not mention AI in any way? And I don't see that at all. And it's beyond just the politics of mentioning a buzz topic. I think it is influencing a lot of the design choices, a lot of the technology choices, people choices, software choices, and so on. So I think they have become intertwined in a way that's not easy. Even if they have divergent requirements, I don't think that intertwining is going to be easily separable for the foreseeable future.
I'll give you a hot take. I think it's likelier, not certain, but likelier that in the future you would go to an HPC conference and not call it HPC. You'll call everything AI, regardless of whether it's AI or not under the covers. I think that's likelier. Thanks, Andrew. Say something and then go.
I'm just going to add, I think there's too much of a sense of belonging in this community to give up that HPC label that easily.
Yeah, I didn't say likely, I said likelier. Thank you, Andrew. We need to do quick changes here. This is a fast panel. And Andrew's right, there's so many different topics here. We could do a whole hour on any one of them. Marek, please come in and introduce yourself, who you're with.
I'm Marek, a recovering particle physicist. Been working as an HPC manager in Cambridge at the Faculty of Mathematics for a few years now. I'm also involved in the radio communications resilience activities in the UK, and until last year I was a developer of Gentoo Linux. As for this agreement, I mean, it's really hard because we've got really good coverage of the topics on both sides largely, but one thing I kind of feel might have been omitted is the problem with, is there actually a future for AI and HPC, or in general HPC, because what I'm talking about here is the resilience matter. We have been for quite a few years now, if not more a decade even, concentrating the supply chains from fewer and fewer vendors. It's already very, very difficult to get certain hardware, and it's going to get even more difficult, essentially, since we are very much in a bubble, and maybe from what I hear, people at the conference tend to be more relaxed, but in industries, they're much, more AI factories, more, give us a nuclear reactor. Yeah, let's say, leaving aside the fact I'm not entirely comfortable with giving, entrusting nuclear reactors to the industry whose motto is move fast and break things. I really feel that there are so many things that can go wrong in the current geopolitical climate, that it might find out that even in something like a year, we'll find out it's literally unable to build any more
There are a
AI
couple
resources.
different directions I could take that comment. The one I'll pick on first is the notion of more and more going into hyperscale. And we've even seen NVIDIA investing in a new generation of AI-centric clouds. And with that and the cloud companies, I did this without Andrew up here, but the notion of everything as a service really continues to build to where on this current vector, we could hit the 2030s, maybe not within the 5-year forecast, but next decade, where everything as a service really starts to become a reality, and on-premises computing is a much scarcer thing. How likely do you think that is, and how would HPC start to evolve to that? Go ahead.
So, well, I'm talk for Europe, that we saw how HPC has been more an academic kind of game so far, but we understand that it has to evolve from that. In the traditional environment, you had your users really being supported in a specific supercomputing center, building close relationships with specific scientific domains. Now we realize that by expanding this, by moving to AI workloads and to AI community, which is coming really from different backgrounds, the focus is on services. The focus is on support, is on skill development, and providing the necessary software layers that will enable computing without too much hassle and not too much diving into specific architectural requirements. So in this sense, indeed, there is a move towards more on a service-oriented approach of offering.
Horst.
I wanted to ask another question since I have the microphone. And this is about AI in HPC. And so since there's a whole audience of about 200 people who are HPC experts mostly, so I'd like to ask you to raise your hand if you have successfully applied AI to solve a genuine HPC problem. maybe define a configuration for a system, improve on a benchmark, anything like this? Oh, good, Torsten has. Good. I'll talk with you later, because
He's not very credible.
okay, the reason I ask this is because I thought about AI and HPC, and so I can start at the low end. I always said, I wonder one AI would be ready to solve the first homework assignment in my class in CS267 in Berkeley, which is solve a matrix multiply, get the fastest performance on your home system. Just read the architectural description of your home computer and then optimize matrix multiply. And I doubt that any AI today can do this. And then I said, in terms of a question, will AI replace us? And I can say this with a very strong no. AI will not replace the HPC experts in this room. And a perfect example was the meeting I had this morning with some colleagues from NVIDIA who described how they used the Osaki scheme implemented on various of the NVIDIA process. And while I was sitting there listening to my colleagues, I said, will AI ever be able to do this, taking a paper that describes Osaki scheme, which is already in itself, the Osaki 2 seemingly is a very difficult description, and then implement this on a very particular architecture? And I don't think that will happen in 10 years. And if it is, you know, I like bets. I'm willing to bet, again, 2,000 euro that you can't feed the Osaki 2 paper to a ChatGPT-like system and it will produce an optimized code on the NVIDIA.
In what time frame do you bet that 2,000 euros?
2035.
But you might find a taker in here. Marek, you were at one point nodding and at one point shaking your head. What are you thinking?
Well, disclaimer, I love as a service model, just not in the way the hyperscalers would like us to use it. I love doing things in a flexible, software-defined way on my own infrastructure, but I really don't feel comfortable in trusting these resources to the outside for several reasons. One, having been watching for the last few years how essentially most of the UK academic sector is being forced on the general IT side of things into the cloud, and seeing how those things fall over on a fairly regular basis, and in the end you've got local IT teams who've got neither, okay, they might even have an idea what is going on, but they've got actually no way of fixing that unless somebody across the Atlantic flips the switch. Big and... So yeah, let's imagine something breaks, that's one thing. Another thing is, okay, so you've got all this cloud infrastructure, and you rely on that to be running, and who is actually going to maintain that infrastructure? Because yeah, of course, now right now you can say you've got the brain drain from academia or whatever into the hyperscalers community, but then we go back to this problem mentioned by Scott that, okay, so now we've got a new generation of students who essentially they work on Jupyter, they've got no idea what SSH looks like, and they're not really interested in learning. So who is, in the long run, going to be maintaining those systems? And if we don't have on-prem, chances are it will be very, very short, we'll end up in an even shorter supply of people who know what they're doing than we already have.
Vangelis, go ahead.
So I always believe that our the benefit of the traditional supercomputing setup comparing to hyperscalers is the human interaction, the fact that the user had real support from people that they were know what they were doing. I think as we are evolving from traditional supercomputing to AI, we will keep this kind of traditional relationship.
Horst, you're a minute overdue. Yes. I'll give you a closing word, but not a 4-point response. Go ahead.
Closing word, I didn't give the answer to my 4 scenarios. I think the future will be good and HPC will be in it for better or worse.
Thank you very much, Horst. I appreciate it.
Next is Hatem, but we should again ask also for other volunteers, in particular, where's women in HPC?
All right, Hatem, come on up and introduce yourself.
All right, I'm Hatem Altayef. I'm a principal research scientist at KAUST. I work in linear algebra and mixed precision. And I have to disagree, I guess, with all of you. Well, I mean, one of the main challenges that we face in our community is those papers that are being submitted with ChatGPT, and that's great. It's a nice tool for the author to quickly get their ideas, framed into a paper. But the problem is, we still have human behind the scene to review those papers, and this year was an incredible challenge at supercomputing, and we expect that trend to, be in the future. And we're still looking for ways on how we could equip, the PC members with some, AI tools, to help them review efficiently, those papers. But we don't want to end up having an AI versus an AI talk to each other, right?
I love this idea of humans. Let me pick up this through line and combine it with something Marek said before, because we've had a big focus on community and connecting the dots at this event. But Marek also mentioned this essentially rising tide of nationalism and sovereignty with respect to HPC and AI. So my question is, how should this community be behaving in the face of that rising notion of HPC and AI sovereignty? Include the notion of cross-border scientific collaboration. Does that get harder? Do we have to focus on it? Or what about users buying supercomputers that come from vendors in another country? Like, we can't do that. How should we behave in the face of all this? You rose the topic, so go ahead.
One thing that immediately springs to mind to me here, that in the end there's nothing new in history, because that's to some degree what happened in at least parts of the scientific field during the Cold War era. There was a close collaboration, for instance, between JINR in Russia and CERN in Europe. So yes, of course, there are two blocks which are very much hostile to one another, but there was scientific collaboration. So that's actually, in that case, we've already got the playbook in there. Of course, you might have already forgotten some of the playbook, if not most of it, but there is experience you could draw on still. The problem is that at this point, I really feel that's because actually the problem it might be for me that actually it's more blurry at this point. There's no strict us or them, black or white, regardless of what certain politicians would like us to think. So it's getting difficult. Is choosing this particular system or not choosing this particular system an actually justified decision? Is there a lobbyist behind this, or is there a false information behind that? And that's something that's making it harder to figure out. Because personally, I really believe in large-scale collaborations, but at the same time, but not in the sense that you entrust everything to foreign. What would be a polite way of saying that?
What would be an impolite way of saying it?
Foreign agents, whichever way of agent you want to employ, you want to use in this context. Yeah. So that's a tricky bit.
Evangelos.
So I mean, I think my point and my focus is that AI is changing things. AI is disruptive. I think our generation were the first ones to introduce the internet, and we grew up through that, and we saw how it changed the world, and we embraced it, and we move it forward. And I see now the new generation coming. I see my son, he's 13 years old, and he's using ChatGPT to help him building Roblox worlds. I don't use ChatGPT almost for anything. So this new generation that is coming, the AI will be as a given for them. This is the civilizations they will be building on, and I see this as a responsibility for us to deliver to them on an ethical and trustful way, in order to preserve this human aspect of the AI, of the computing infrastructure given to society.
I like that answer, because let's take the threat out of learning a new way of doing things and introducing new ideas, particularly hiring new generations of talent. I find I wind up learning more about how I can improve my processes as long as I'm willing to let go of that's not the way we do things and get off my lawn. Hadam, what do you are you seeing this at KAUST also?
Yeah, I mean, big time. We have to be open-minded. We have to be inclusive. Be bold sometimes also to let new ideas and new people try new things, and making sure they're on board with us in whatever we try to carry on in some of our research projects. One of the things is to be open-minded, and having the ISC as the main HPC event in Europe. I look at the prompt there. It says in 15 minutes we have this HPC around the world, right? That's a great program that ISC has been doing that gives a platform for those underrepresented countries around the world in Asia, Pacific, South America to come and tell their challenges, explain where they are and where they would like to be heading and looking for collaborations. And I think those are really inspiring initiatives that we need to promote and keep promoting within our community.
Evangelos, anything else you were hoping to get to say while you're still up here?
So if these are my last words here. So I want to reiterate our goal as EuroHPC, as Europe. That's certainly we're focusing on AI this next couple of years. There are big things coming. We are very serious about our contribution and what AI is bringing, the disruption in the society. We also from EuroHPC side, we don't forget our origins. We remain EuroHPC. So the coupling of HPC and AI for us will remain a focal point.
I have to ask you one more thing. I'm going to break my own rule because I have to ask you before I lose you. How important is sustainability going forward to EuroHPC as a topic?
I think it's part of the European culture to always take into consideration sustainability.
We're going to be able to stick with that topic with a new panelist. Thank you very much for being up here with me.
So now I take the joker.
John, okay.
Hello, I'm John Chow from Berkeley Lab, and things to disagree with, so I'll start with disagreeing with Addison, because he said that HPC would be subsumed by AI. I think it's the other way around. The AI people are tripping over each other, saying that they got HPC systems, which they do. And the second is that there is a...
I will bet 2,000 euros of Horst's money on that.
On that, okay. Let's go spend Horst's money. And so the second is people talk about needing general purpose machines. And so if that's true, then why do we invest so much in quantum? Because that's as specialized a special purpose machine as I can imagine.
I like that. All right, now I have to stick with this topic of sustainability, though, because we have to get to this in this panel, and we're going to run out of time. But I will tell you, I do this vendor showdown session, and a couple of years ago, it must have been half of the submitted presentations from vendors had some phrase around net zero by with some year in it. I haven't heard that once this year. And there's certainly been a cultural change in the United States around it. I think parts of Asia. Europe might be the last remaining stronghold. We are talking about reducing power consumption, but sustainability not quite the same thing. How much do we need to be focusing on that as a topic at ISC, Marek?
Very much, I would say, because as I mentioned earlier, so we've got hyperscalers or whatever, essentially the industrial bubble running ahead as like crazy. And I found this very disheartening. Like 2 years ago, so sustainability, everybody was wiping their mouths with net zero, like you just mentioned. Now, like, people came up with this LLM, so fuck it. We're just going to put more power into it.
They can edit that out in post, right?
Yeah.
Okay.
Yeah, and then basically, but literally that's the way I use the word specific because literally I felt that was the attitude that happens. So and now everybody just throwing more and more power at data centers without even asking what's going to come out of that. For the record, I find the idea of using, I still don't like the phrase AI in this context, an LLM as a summarizing tool, a very cool one, and once it actually works, I will be very happy to do that. Just at this point, where I literally have to fact check everything this thing produces to me, I would rather just do it myself. And my son likes doing prompt injection on the various models, which is quite fun. But yeah, anyway, so I think we cannot keep this up in the long run. Because, yeah, of course, one might have the miracle will happen, and in 2050 we'll have working commercial fusion reactors. But we've got 25 years to go until 2050, and we do have to survive until that point. We're not really talking about... I am serious. I am really concerned about the long-term survival, rather just because... overall situation, I really don't want to waste precious resources on something that's going to turn out to be an expensive toy.
Burn, baby, burn. Hatem, is sustainability a topic at KAUST, or should it be? Where is it?
Well, I mean, it is, sure. But I'd like to look at it from an algorithm point of view and software development point of view.
Okay.
Looking at various hardware architecture available out there, it is important to develop sustainable code. And, luckily we have those, standard programming model that helps us, move, from one architecture solution to another one. And those are really helpful to keep in mind when developing new algorithm, new, targeting new applications. So those are important aspects to consider as well when it comes to sustainability.
All right, John, what do you think? Yeah, I've seen a shift in sustainability in the U.S. I don't know about you.
No, it's like a V cycle. They were heading towards that top target, and then you see them going back up again. There's somebody said it was hyperscalers make $5 on every dollar that they invest in GPUs, and so that cycle just spins up. For us in HPC and the sciences, we've got a cap. We can't be building out power plants. We're not operating nukes. Something that was said earlier that did resonate with me is why do we want to entrust a compact modular nuclear reactor to somebody who moves fast and break things as their mantra? That does seem problematic. I will say I attend a lot of hyperscaler conferences and meetings, and they have tracks on sustainability that are growing in the inverse to how much power they're consuming. And I also wonder if we are using AIs to generate code for us, is the carbon footprint from that is probably a lot larger than a graduate student with ramen noodles.
What's the role of this conference then in terms of setting the conversation against the backdrop of the AI market is bigger than the HPC or supercomputing market that we typically see here? Do we even have an influence?
Well, or we're not the problem.
If we're not the problem, do we have any responsibility, or should we just say, well, they're those kids these days?
Yeah. No, we need to deliver more science with less power, and that's the only way we're going to get around the slowing of Moore's law.
All right, Mark, anything else you want to say while you're up here?
I must say I very much agree with John on that bit, because I'm a pessimist by nature, but if everything starts crashing and burning, then what we manage to salvage by being more efficient will be what will matter in the long run, not what's happening right now, I hope.
All right, Mark, thank you very much for joining us. Torsten, your turn. Get up here.
I had to do the Hatem jog here to go to stage. So my name is Torsten. You've seen me in the opening session, so I'm at ETH Zurich. So I have to disagree with everybody, unfortunately, but you will not give me enough time to actually do so. So I will summarize it. And the overall.
I can't stop you, Torsten. You do what you do.
But the overall vibe in the panel that I've seen is a little bit negative towards AI. It seems like. You're like,
oh, look at that. That's a great topic. I should have had you up here a long time ago.
Exactly.
It's an HPC conference.
Exactly. It was exactly like, it's a threat. You roll in with like it's the killer app and we're all getting killed and I'm feeling threatened.
A lot of people read that article.
But I have to say, I completely disagree with this. I believe AI is the biggest chance, the biggest opportunity our community has had since my lifetime. And let me explain why. We can actually look at this. We can look at if AI was the killer app, AI has been growing exponentially in the last couple of years, our community would be shrinking. No, our community is growing with AI. The attendance records of conferences we are seeing this year, we are most likely going to break the attendance record of ISC ever, so we'll wait until tomorrow until I officially say it, but it's looking good. SC has been breaking attendance records, so all of our HPC, our field is flourishing. My students make 5 times as much money as I do when they go into industry. No, I'm not kidding actually, which is sad. for me. So, but this, look at this. We are flourishing, but then it's like, it's the killer, blah, blah, blah. No, it's not.
I have to defend that article a little bit, because if you actually read the article, as opposed to the headline, in the conclusion, I say very definitively that HPC is going to survive, but we've had other times in our industry where we've had significant modification to the way things are done. Look at the cluster revolution coming from SMPs and vectors into clusters and MPI. There was a significant disconnect in the industry, and there was a decade of that's not capability computing, that's capacity computing, that's not real HPC, you don't get any efficiency out of it. That was a conversation we had for a long time before the industry gradually migrated to clusters. So I'm very real about the idea of, do we have to adapt to lower precision? Where is it appropriate? Do we have everything as a service? None of that kills HPC, but it might change it quite a bit.
First of all, exactly. First of all, I mean, who's going beyond headlines of articles? You present us the headlines. I'll ask Copilot to summarize your article, and then we'll see.
I write these 20-page methodology sections. No one reads them.
Well, Copilot will read it. You know,
Super.
It will summarize it for you. Don't worry. You will be ready.
And you don't want me to be anti-AI.
It's totally okay. But let me actually elaborate on my argument.
Please.
Why AI is good for our community. Because I have been, like, when I came into ETH 14 years ago, no, 13 or so, a long time ago, I started talking to the weather people. This is where I later learned to get to know Bjorn. And I started talking to them, and I told them, "Are you sure you need FP64?" They're like, "Yeah, absolutely. We have tried everything to reduce FP64 to lower precision and whatnot, and there is no way we can go lower." That was an argument I've heard for about 4 or 5 years. And then the first machine learning people showed up. It's like, yeah, single precision is good. Yeah, half precision is good. And they were like, ooh. Right. They were moving fast. Ooh. And then suddenly, now Swiss weather forecast is run on single precision, and we are actually looking into lower precision. So this is a good nudge that the community actually needs to go forward. This is positive. Like we are sitting here in our old mindset, and then comes a new thing zooming by. We're like, ooh. What just happened?
I heard no less than Dan Stancione say this at the Rice conference. You're going to give me 8 times as many flops and they'll be 40% less efficient. That sounds like a good deal.
Well, I mean, we're not talking Jensen flops here, but
yeah, I don't know.
John?
I'm going to disagree and agree with Torsten at the same time, which is invoking what was said earlier. To the AI will help me with a lot of the boring things that I don't want to do, and a lot of what we have to do to get to the interesting stuff is do a lot of boring stuff. Bjorn said AI automation is great for doing the repetitive stuff I don't want to do. So to that extent, big opportunity.
I got to disagree with Bjorn as well here. We had an argument down there, actually. So, sorry, may I?
Yeah, go.
Yeah, that just so I actually there are multiple examples where AI has produced new scientific insights that humans later studied and understood later that it was actually a very good move. So one of the things is move 41 or so in the Go play. That was the world famous Lee Sedol was beaten on public television by the first system, an AI system playing Go against the best Go player on the planet. So humans thought it was a really stupid move when they came. They were like, oh, now the AI has lost. And then, 5 minutes like, ooh. And then they studied it for years, and they found, oh, it was actually a very good move. So there were many of these examples of mathematical proofs. Those were mostly in proof systems that were actually provable. Science, what we do today, is not as provable. So I kind of disagree with Bjorn again, because very often this is a mathematical thing, like you apply little tools to things to solve it, but you apply them in a creative way with good guessing, and so this is what we humans do. So in some sense, this is going to be quite an interesting, long discussion. So we have 2 minutes left. I will not go into this, but if you want to discuss it, I am happy to battle it out.
Oh, this will start a lot of discussions. Hadam, you have.
I just want to say, I think the future of AI is HPC. I think we let the AI folks get tired doing brute force things, and then eventually, when it becomes, a mandatory goal to, watch, the power consumption, watch, many other constraint, money, the time used to train those large language models, they'll come to us. And then
AI is HPC today.
Well, sure, okay. I mean,
it will remain.
We need to build those bridges. I mean, that's what I'm trying to say here.
Yeah.
There's no bridge, it's the same. It's the same.
I don't think Move 41 was explainable, and scientists HPC experts, mathematics experts had to explain it after the fact, but I don't believe that the AI has any internal explanation for it.
So as a moderator, I feel like I can
explain
get to the end of a Fishbowl panel, and I don't know, I feel like For me, it's a successful Fishbowl panel if the conversation is really going and we're out of time, right? Because the theme of ISC here is connecting the dots. And the whole point of this format that I like so much is we introduce a lot of topics and we find that there's room to disagree and yet have really constructive conversations about it. What I love most about this community is how smart everybody is. And it's not that I think I'm dumb, but I come in here and all I do is learn all week long and make these fantastic connections. And I've got now 12 different conversations I'm dying to follow up with people when I get outside of a 60-minute panel. So everyone in the audience, if you've enjoyed it as well, please join me in thanking my panelists today. Yutong Liu, Bjorn Stevens, Scott Ashley, Andrew Jones, Horst Simons, Evangelos Flores, Mark Zuba, Hatem Eltayev, John Schaff, and Torsten Hofler. Thank you for joining me up on stage.